So already we know that we have worked on these areas in our last class, but just for a clarification, I'm just giving a brush up again. Point mass collision with a rigid body is a greater application area in rotational dynamics. You take a case A, which is a fixed axis system. Now, in a fixed axis situation, please remember, do not apply law of conservation of linear momentum. Why? Because I have clearly explained at this point you will have a hinge and that acts as an external force, and hence you are not supposed to conserve linear momentum. But about this point, you can conserve angular momentum. In this case, how many unknowns? Usually, unknowns will be final V omega. These are two unknowns. You require two equations. One equation is law of conservation of angular momentum about the hinge point. The other equation is, see, they will give you some information about either coefficient of restitution or kinetic energy conservation information, something like that, or the final velocities, or something like that. They will give some information. Whereas in case of a free axis means just assume that you placed a pen on the table and you are giving an impulse. So in this process, what will happen is you can conserve law of conservation of linear momentum. You can apply law of conservation of angular momentum. But my point is just apply just below the point of center of mass. Also, some information about the initial and final kinetic energy or nature of collision will be given. So these are the basis for whatever that I am going to discuss today. Right. This is an HC Verma question. Even previous class also I have given lot information about HC Verma question only. Because they are very fundamental in nature related to this aspect. Now read the question carefully. Uniform rod of mass M and length L is struck at the end by a force F perpendicular to the rod for a short interval. It is called impulse. So impulse is J into impulse is equal to J, which you can write it as F into T. The speed of the center of mass, the angular speed of the rod about the center of mass, the kinetic energy of the rod, the angular momentum of the rod about the center of mass after the force has stopped to act. Here T is very small, right? Right. Now the question is, this is on a horizontal table. At the end, you struck here. So law of conservation of a linear momentum gives you the condition J is equal to F into T is equal to MVCM, equation 1. Any doubts? Clear? Now, one more important point is law of conservation of angular momentum step. This is called angular impulse. J into L by 2 is equal to I omega ml square by 12 times, because you are applying impulse at a point just below the center of mass. So therefore, J into ml square by 12 omega. So therefore, with this you can write J as ml omega by 6, equation 2. So how many unknowns were there? VCM and omega are the unknowns. I have two equations. Now clearly, one implies velocity of center of mass is equal to F into T by M. Clearly, equation 2 implies angular velocity is 6ft by ml. You asked speed, angular, kinetic energy of the rod. The kinetic energy of the rod will be two parts. Ke is center of mass plus Ke pure rotation about center of mass. PRCM means pure rotation about center of mass. This is equal to half m VCM square plus half I. I means this is ml square by 12 omega square 36 f. Okay, 1 minute. 1 minute. 36 f square t square by m square el square. Clear, Anna? Sure? Right. ఇంకే ఉంది దీన్ని సబ్స్టిట్యూట్ చేస్తారు మీరు. Finally, this is f square t square by 2m plus correct? Now what you are going to get is 2 times f square t square by m. Please confirm. Have you understood this question or not? Clear? So you asked me totally 4 things. I have given Ke of the rod. You want angular momentum of the rod about the center of mass. Angular momentum about the center of mass is simply ICM omega. And you know everything related to this. ICM omega. Are we clear now? Just please confirm whether you have understood these steps or not. Sure? Paka? Right. Next step. I'm going for the next question. Now try this question. They're all very good questions actually. Uniform rod of length L lies on a smooth horizontal table. A particle moving on the table strikes the rod perpendicularly at an end and stops. Find the distance traveled by the center of the rod by the time it turns through a right angle. So that if the mass of the rod is 4 times that of the particle, the collision is elastic. Right. Find the distance traveled by the center of the rod by the time అక్కడే ఉంచు చెప్తాను లేదా ఓకే ఇక్కడ తీసుకొచ్చి అంటే టేబుల్ మీద పెట్టి పాస్ ఓకే 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 రైట్ ఈజ్ 4 times that of the particle, the collision is elastic. No. రామకృష్ణ అరగంట తర్వాత టీ తీసు రైట్ యూనిఫార్మ్ రాడ్ రైట్ ఓకే ఫైన్. వాట్ ఈస్ ద డీల్? What is this case coming under, free access or fixed access? Free access to, first you can apply law of conservation of linear momentum. By applying law of conservation of linear momentum, you will have mv is equal to mvcm. Sir, you are cheating. No, I'm not cheating. See, strikes the rod perpendicularly at an end and stops. Distance traveled by the center of the rod by the time it turns through a right angle. No issues. Okay, first equation is done. First part is done. Any doubts on this? Next. Now, what is the best point? Law of conservation of angular momentum. About a point. What is my reference point always? About a point just below center of mass of a rod. Right. So therefore, L initial is L final. Okay, now you said that uh, you have point mass moving with velocity u. This is the situation just before now try to please see that this is initial situation. This is VCM. Remember, this is coming to rest. And this is how it rotates. Yes or no? Why? Because you have given impulse in this direction. About the center, the nature of the impulse is anticlockwise. Are we clear till this point? Remember, this is initial and this is a final situation. Therefore, my point is L initial will be simply M V L by 2 is equal to L final is ml square by 12 omega, which implies mv is ml omega by 6, equation 2. How many unknowns did you notice till now? One is VCM. What are unknowns? VCM is an unknown. Omega is an unknown. What else? VCM, omega, and the final velocity. Of course, they have given the final velocity, fortunately. So I think these two equations are just sufficient. But one thing is clear, small m and capital M by ratio is also unknown. Right. For that, I request one more equation. Now you said the nature of the collision is, where is that line written? Show that the mass of the rod is 4 times that of the particle, the collision is elastic. Ah, So elastic collision means E is equal to 1. Tell me please, what is the velocity of this one finally? VCM plus L by 2 omega. E1 means VCM plus L by 2 omega minus 0, because velocity of the second body after collision is 0. V2 minus V1 is equal to U1 minus U2. Coefficient of restitution 1 means. So therefore, that is V minus 0, equation 3. Now you have three equations. So solve these three equations, or else draw the data from equation 1 and equation 2 and post it in equation 3. For example, VCM can be written as M by capital MV plus L omega by 2 can be written as 3mv by capital M, minus 0 is V, which clearly implies 4 small m by capital M is 1, or small m by capital M is 1 by 4. Any doubts? Please confirm, have you understood this or not? If we are clear, we will proceed further. Sure? Paka? May I proceed for the next question? Now, I am giving you time. I am assuming that, yes, whatever that the data that they have given is fine for me. And the difference between the previous information, the present information is that the collision and it sticks to the rod after the collision. It is sticking to the rod after the collision in this case. Now see, again they have given you one information. Now you go with everything same, but only difference is in case of sticking, in case of sticking, this is like a center of mass of a rod. Once it sticks here, center of mass of system. So you have center of mass of the rod and center of mass of the system. They are different things. You assume that this distance is R1 and this distance is R2. Already we know from the characteristics of center of mass, R1 is capital M by capital M plus small m times L by 2, because the total distance is L by 2. L by 2. ICM is equal to ml square by 12 plus, yes, first rod about the center of mass, and a rod is at a distance m r2 square plus m r1 square. That is the expression for moment of inertia. So this is ml square by 12 plus, trust me, you will get capital M small m by capital M plus small m times L square by 4. Or you again adjust this properly so that you have a comfortable m square plus 4 small m capital M by 12 times. Is this true? I think 3 multiplication factor రావాలి కదా ఇది. You need to multiply numerator and denominator with a 3 actually. Leave it. This is equation 1 right now. Moment of inertia of the system about a point with respect to the center of mass of the system. ICM about the center of mass of the system. Right. The first part is done. What is the second part of the system? You said velocity of the point P. You said that the rod sticks, point mass sticks to the rod after collision. Right. Now see, even now you can apply law of conservation of linear momentum. So which is nothing but equation 2. With respect to center of mass of the system. Agreed? I am writing the system now in the reference frame of center of mass. Here lies center of mass of the system. Now see, try to please understand, just before collision, let this be point P. Let this be, here we need to give some name. Let A stands for center of the rod. So in center of mass reference frame system, this will have VCM and this will have V minus VCM. Agreed? So what is V minus VCM? V minus MV by capital M plus small m. This is nothing but MV by capital M plus small m. Right. So what is the initial angular momentum? There is no rotation actually. Initially, rod has no rotation. But R bar cross MBCM bar term is there. So therefore, M times MV by capital M plus small m times R1, because you said that this distance is R1 and this distance is R2. Capital M times R. That is the initial angular momentum of the system. M capital M by capital M plus small m times V. What is V stands for? Already you know, small m V by capital M plus small m. What is R1? You already know R1. Capital M by capital M plus small m L by 2 plus capital M. Here 1 minute. Why? What made me to write this part? What made me to write this part? What made me to write this part? MV. The entire thing is capital M small m by capital M plus small m V. Similarly, capital M small m by capital M small m V times R2 means small m by capital M plus small m times L by 2. Trust me, finally you will get this as capital M small m by capital M plus small m V L by 2. Any doubts? What is all this? The initial angular momentum. You are doing this in the reference frame of center of mass. Don't forget. You are doing this entire thing in the reference frame of center of mass of the system. This is with respect to center of mass of the system. So what is L final? Simply ICM omega. ICM means system. हो गया ना? Now finally change the color. So what you are going to do is L initial is L final, capital M, small m by capital M plus small m, VL by 2 is ICM. Yeah, what is ICM? ML square by 12 plus capital M small m by capital M plus small m L square by 4 times omega. Boys, so that's the deal. So what do you want? Finally, I think what is that they want? They are find the velocity of center of mass. I have done. Now 1 minute. One by one, I'll check. Find the velocity and center of mass of the system rod plus the system. Done. Find the velocity of the particle with respect to center of mass before collision. Done. Find the velocity of the done. Find the angular momentum of the particle of the rod about the center of mass C before collision. Done. Find the moment of inertia. Done. Find the velocity of center of mass C and angular velocity of the system about the center of mass after the collision. Done. Yes sir, no yaar. Yes or no? Okay, question done. Now please go through and you have any observe. It's a very lengthy question, I know. But this is a very fundamental question. So previous question, no sticking. Present question, it sticks. So both the cases I have demonstrated. Any doubts? Boys and girls? Next. Question number 15. Remember, this is a question taken directly from previous IIT, JEE Advanced 2022. Flat surface of thin uniform disk A of radius capital R is glued to a horizontal table after another thin uniform disk B of mass capital M and with the same radius R rolls without slipping on the circumference of A. As shown in the figure. A flat surface of B also lies on the plane of the table. The center of mass of B has a fixed angular speed omega about the vertical axis passing through the center of A. The angular momentum of B is n capital M omega R square with respect to the center of A. Which of the following is the value of n? That's the question. Right. In this situation, see, you need to remember this formula. ICM omega bar plus RCM bar cross MVCM bar. That's the relation. Now, very clear. I know here pure rolling takes place. For that to pass, VC must be R omega dash. Accepted or not. And by the way, the center is also rotating. This is spinning and rotating. This is spinning and rotating. This spin angular velocity is omega dash. Orbiting omega. In that case, what is going to be VC? This is nothing but 2R omega. Agreed? Will be, if I am saying that the center of mass is moving in a circle of radius 2R, the orbiting angular velocity is omega. And one more important point is this is nothing but R omega dash. So therefore, 2 omega is omega dash. That's my first observation. The angular momentum of B is given. Now, warrior, what is the angular momentum of A? I see M omega bar plus, here omega dash bar, plus RCM bar cross MVCM bar, which means, see now ICM, earlier it is outward, thumbs up is towards you. అమ్మాయి వింటుందా నిద్రపోతుందా? వింటున్నావా అనిక? నీ రైట్ హ్యాండ్ వింటున్నావా? Now the spin rotation, how is the direction of the spin rotation? Outwards, correct, Bhavana. So therefore you can write this as ICM. What is this basically? A disk. What is this basically? Disk. MR square by 2 omega dash K cap plus RCM bar cross MBCM bar 2R into M into its velocity VC. VC is 2R omega. And that is also directed in K cap direction. Now, what is given to you is the angular momentum. What is omega, by the way? Omega. A flat surface, another. What is omega? I want to find out in terms of omega actually. Either they have given. The center of mass of B has a fixed angular speed omega. So don't write it in omega dash. Express it in terms of omega. Now omega dash can be written as a 2 omega. Finally, this is mr square omega 2 into 2, 4 mr square omega K cap. And this is finally 5 mr square omega K cap. Now please tell me, do you have any doubts? One single point, that's the answer. Only thing that you need to see is orbiting omega. In fact, they have given you orbiting angular velocity. Any doubts? May I proceed further? Next question. Right. Yeah, this is my name. Usually, any teacher who comes here, I'll ask this question in the interview. Because if he knows this, he knows the entire rotational dynamics. Right. Go through the question. You have a thin rod, mass M, length A. And in fact, it is free to rotate in a horizontal plane about a vertical axis passing through O. A thin circular disc, mass M, radius A by 4, is pivoted on this rod with its center at A by 4 from the free end so that it can rotate freely about the vertical axis. As shown. Assume that both the rod and disc has uniform density and that remains horizontal. This is also a very important term. An outside stationary observer find the rod rotating with angular velocity omega and this part 4 omega rotating about, which means spin 4 omega orbiting omega. Now you first take a rod. What is the angular momentum of the rod? The angular momentum of the, first of all, I rod you require for this. It is a simple, about an axis passing through one of the end. So I rod times omega. Agreed? Which means ma square by 3 times omega. Agreed, boys and girls? Next. L rod is done. Now L disk. The problem with the disk is the disk has a spin as well as orbital. It is like ICM omega bar plus RCM bar cross MVCM bar. Right. Disk about this axis is mr square by 2 4 omega. Any vector in this direction I'll represent as k cap now. K cap plus RCM 3a by 4 times m times what is VCM? 3a by 4 times omega. 3a by 4 times omega k cap. M a square by 8 k cap, omega 8 k cap. And this is also k cap actually. Plus 9 by 16 m a square omega k cap. Now overall L system is L rod plus L disk, which is ma square by 3 omega plus ma square by 8 omega plus 9 by 16 ma square k cap. Solving which you will get this as 49 by 48 ma square omega k cap. Now please tell me, do you have any doubt at any stage in this question? Any stage, boys and girls? Clear? So what is that they are asking is, find the value of n. N will be 49. Ante kada? Yes or no, yaar? Clear? Shall we proceed for the next question? Are you sure that you have understood every element? See, I don't see 22 same question came, 21 same question arrived. Almost same. Right. 62. Make sure that you do this question. Read the question carefully first. Really, this is a simple question. This is also from H.C. Verma. Two small balls A and B, each of mass M, are joined rigidly by a like ring. Cinema theater lo the rod is clamped at the center in such a way that it can rotate freely about a vertical axis. Remember, it is a fixed axis situation. The system is rotated with an angular velocity omega. About the axis. Particle P of mass M kept at rest sticks to the ball A and the ball collides with it. Find the new angular speed. Two small balls A and B, each of mass M, are joined rigid, right? Now assume the arrangement is like this. And this is the center. And the rotation is happening like this. A particle P of mass M kept at rest sticks to the ball A as the ball collides with it. Find the new angular speed of the rod. Okay. A, B, M, M initially and omega 1, omega 2. Finally, remember, you can conserve the angular momentum of the system still about the axis of rotation. Law of conservation of angular momentum apply about axis of rotation. Initially, moment of inertia is 2 times ml square by 4. I don't think there is a rod for this. Rod is of negligible mass. Light horizontal rod of length L. What about I2? I2. I2 is 3 times ml square by 4. So I1 omega 1 is equal to I2 omega 2. 2 times ml square by 4 omega is equal to 3 times ml square by 4 omega dash. So therefore, omega dash is 2 by 3 omega. That is the deal. Any doubts? Please ask. Are we clear? It's an easy question actually. What case this will come under? Fixed axis situation. Yes, a very good question actually, this one. Go with this. This is also from Irido. Sorry, HC Burla. Two small balls A and B, each of mass M, are joined rigidly to the ends of a light rod of length L. System translates on a frictionless horizontal surface with a velocity V naught in a direction perpendicular to the rod. Okay. Actually, the velocity of center of mass will also be V naught initially. Right? A point P of mass M kept at rest on the surface sticks to the ball as the ball collides with it. Okay. So I need to show you two different situations. Right. The best point what you suggest is center of mass. So velocity of the center of mass of the initially for the rod actually. So what is the velocity of the center of mass of the system? Right. That's the center of mass of the system. That is the center of mass of the system as a whole, right? And you know clearly that this is at a distance of r1, and this is at a distance of r2. We clearly know r2 is 2m by 3 ml, 2 by 3 times of L. R1 is obviously L by 3. You please confirm whether you have understood this R1 and R2 points. Are we clear? Pakka? Right. Now we have a clear-cut idea about VCM. Now what I am going to do is, clearly from this point of view, what I am going to do is, I am going to find the initial angular momentum with respect to C frame. Okay, just please help me. What is the angular moment of inertia of the system about the center of mass? Simple m r2 square 2m r1 square. M r2 means 4 by 9 L square plus 2m r1 square. 6 by 9, 2 by 3 ml square. Initial angular momentum of the system with respect to center of mass. So I am writing the first particle. Iska. Actually, the first particle will have a velocity 2v naught by 3. Because, see, what is the velocity of center of mass? 2 by 3 v naught. So therefore, what is the velocity of, in the C frame point of view, this one will have a velocity v naught by 3. This one will have a velocity v naught by 3. And the point mass will have a velocity 2v naught by 3. M. Agreed, boys? Right. What is the initial angular momentum of the system? Li is equal to, first apply for this. Center of mass is here. And this is at a distance of 2L by 3. And this is at a distance of L by 3. So therefore, M into V naught by 3 into 2L by 3 plus, ఒక్క మిస్టేక్ చేస్తారు, దీని ఆపోజిట్ డైరెక్షన్ లో ఉంటుంది. Why? Clockwise. Even point mass also clockwise. This one will have anti-clockwise sense. So M times V naught by 3. 1 minute. I need to write this minus mv naught by 3 L by 3. But plus m 2v naught by 3 L by 3. Please help me. Overall, what is the picture? What is the angular momentum of the system? Overall, denominator is 9. mv naught L common 2 minus 1 plus 2. 4 minus 1, 3. This is nothing but mv naught L by 3. 3 numerator, 9 in the denominator. So 3. Right. 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 MV naught L by 3. That is L initial. L final. ICM omega, simply. So MV naught L by 3 is 2 by 3 ml square omega. Any doubts on this? First, any doubts on this? Hello? And that's all. You got a omega term. Notes under there. You got omega term. Ever notes తీసుకురాకుండా please see that and you confirm me whether all that what they questioned, whether we have done or not. Just please see and confirm. The linear speeds of ball A and B after the collision is what we require. Everything I can find with this data right now. Trust me. Now see in this, finally what you got? You got the value of omega here. L omega is nothing but 3 gets cancelled, V naught by 2. Right. And you already know the velocity of center of mass is 2 by 3 V naught. You already know this. Now you want any point, like for example, you want the velocities of these points. Now see, this will have two things. One VCM and the other about the center of mass. So 2L by 3 omega. The other part here it is VCM minus L by 3 omega. That's all. What is VCM? 2V naught by 3. What is 2L omega V naught by 3? This is equal to simply V naught. What about this? VCM 2V naught by 3. L omega by 3. V naught by 6. What is going to be the value of this? 2V naught by 3 minus V naught by 6. Entera? V naught by 2. That's all. If you have any doubts, please ask me. Are we clear about this question? Paka? Now try this, everyone. We have only 5 minutes, not even 5 minutes, 3 minutes time. The angular momentum of the disk at the instant shown is. Please try to understand angular momentum about which point. There are 2 points. See, general formula L bar is equal to ICM omega bar plus RCM cross MVCM bar. No. If you take A as the criteria, okay, for all the situation, ICM omega bar is fixed. This is a disk actually. MR square by 2 omega K cap. That's fixed. Okay, that is a fixed. Right. Now about A, you take L bar is ICM omega bar plus RCM bar cross MVCM bar. That is MR square by 2 omega K cap plus. The problem here is 0. Anyone explain why it is 0? చెప్పు సుస్మిత, రక్షిత చెప్పవా ఎందుకు 0 అది? భావన చెప్తావా? కాదమ్మా, అస్సలు మనం ఎంత చెప్పినా మళ్ళీ సోషల్ స్టడీస్ అవుతుంది మీకు. దాన్ని కొంచెం టెక్నికల్గా చెప్పు అక్కడ. ఓకే, నువ్వు నీ ఫీలింగ్ కరెక్టే, జస్ట్ రిప్లై ప్రాపర్లీ. ఆర్సిఎం బార్ ఏ డైరెక్షన్లో ఉందో విసిఎం బార్ కూడా అదే డైరెక్షన్లో ఉంది. అప్పుడు ఆర్సిఎం బార్ క్రాస్ విసిఎం బార్ ఏమవుతుంది? 0. నెక్స్ట్, నౌ అబౌట్ బి. If you take it about B, RCM bar VCM bar into the plane ఉంటుంది. Why? RCM VCM, your thumb into the plane of the paper. అప్పుడు ఎలా అవుతుంది? ఈ డిస్టెన్స్ 3R M VCM K cap. By the way, VCM is R omega. So this will become MR square by 2 omega K cap minus 3R MR omega. Okay, this is minus 5 by 2 MR square omega K cap. This is about B. Boys, please confirm, have you understood my observation about B? Yes or no? About A, about B, right? Now what else left is L about O. About O, L bar is ICM omega bar plus RCM bar cross MVCM bar. ICM omega bar. What is ICM omega bar? MR square by 2 omega K cap plus. ఇప్పుడు RCM బార్ క్రాస్ అంటే ఇప్పుడు యాక్చువల్గా ఇది RCM. ఏముంది పర్ఫెక్ట్, ఆల్రెడీ అబౌట్ బి ఏంటో అబౌట్ ఓ కూడా అదే. Both are fixed actually. About O or about B, R bar cross MVCM bar is the same. Yes or no? Right. So therefore, this is again minus 3R MR omega K cap. So finally, you will get this also as minus 5 by 2 MR square omega K cap. So 5 by 2 MR square omega about O, about B, and MR square by 2 omega about A. Now please confirm, have you understood clearly these steps? Yes or no? Paka? Sure. Right. Before I go for this, I'll first do this question. Please go through this question carefully. A ball of mass m moving with a velocity v0 experience a head-on elastic collision with one of the spheres of a stationary rigid dumbbell as shown in the figure. Mass of each sphere equals to m by 2, and the distance between them is L, with the rod connecting them being massless. Sizes, you can find the angular momentum of the dumbbell in the reference frame moving translationally and fixed to the center of mass of the dumbbell after collision. Right. Nothing to worry on this actually. It's a very, very simple and straight question. Very simple and straight question. Now see, I'm very clear on this. First, Yep. Will this come under free axis or fixed axis? This comes under free axis. So therefore, apply law of conservation of linear momentum. Clearly, I'm assuming that this is initial situation. And finally, what I'm assuming is this is moving with velocity v1. And this arrangement as a whole moves with velocity vcm after collision. This is before collision. mv0 is equal to mv1 plus 2 times m by 2 vcm. Equation 1. So v0 is v1 plus vcm. Right. That is the first point. Apply law of conservation of linear angular momentum about a point just below center of rod. You may ask me, sir, you are doing cheating now. You have changed your version here, whereas you took in all these questions the center of mass of the system. What makes the difference? I told you very clearly. This is sticking. After collision, sticking. So you need to take the conservation, law of conservation of angular momentum point as the center of mass of the system. In this case, there is no sticking. There is no sticking in this case. So in that case, better point is just below the center of the rod. So therefore, initially, what is the angular momentum? Initially, the angular momentum is mv0 L by 2. Finally, it is having some v1 velocity L by 2 plus 2 times m by 2 L by 2 m L square, moment of inertia omega. Right. Rakshita, why I am not writing another term? There should be another term, no, RCM bar cross MBCM bar. You are just below the center of the rod, so therefore RCM is 0. You don't require to write that term. So finally, after careful observations, you will get this term as V0 is equal to V1 plus L omega by 2. Boys and girls, how many unknowns were there for me right now? There are 3 unknowns. V1 is an unknown, VCM is an unknown, omega is an unknown. You require one more equation. What is that equation? Elastic collision. So coefficient of restitution is 1 at this point. So what is going to be the velocity of this point thereafter? It is nothing but L by 2 omega plus VCM. So L by 2 omega plus VCM minus V1 is relative velocity of separation. So what is the relative velocity of approach? V dot minus 0. So you have another equation. So are you convinced with these 3 equations? Yes or no? Please tell me, are you convinced with these 3 equations? Clear? Right. Are we clear? Right. By using these 3 equations, yeah, first of all, 1 and 2 implies right. Any doubts? Clear? Now you got from 1 and 2, you will have VCM as L omega by 2. Right. Now you got L omega by 2 as VCM. Now you again use 2 and 3 equations. You simply use 2 and 3 equations, by doing which you will get that omega term actually. By now you have VCM as L omega by 2 kada. Now you just use equation 3. Equation 3 gives L omega minus V1 is equal to V naught. Whereas 2 and 3 you use. 2 and 3. Ante kada nana, 2 and 3 you use. By using 2 properly, which means therefore L omega is 4 by 3 V naught. Agreed? Array, yes or no? What is that they want finally? Angular momentum of the dumbbell in the reference frame moving translationally and fixed to the center of mass of the dumbbell after collision. Okay, fine. What else you want? What is the initial angular momentum? It is L final is equal to in the reference frame of center of mass actually. That is also an important observation. Simply, and one more important point, not the full system again, only the dumbbell. Means what is that they are asking? L dumbbell about the center of mass is simply ICM omega. ICM is 2 times m by 2 times L square by 4 times omega. Omega is 4 by 3 V naught by L. This is m V naught L by 3. M V naught L by 3. Okay, na? So finally, దాని తగ్గట్టుగా ఆన్సర్ సెట్ చేసుకోండి. 3 చేస్తే 9 వస్తుంది. ఆన్సర్ 3. వెరీ 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 ఇంపార్టెంట్ మోడల్. పాయింట్ మాస్ ఎన్ని చూడండి, మీకన్నా సిగ్గు ఉండాలి, నాకన్నా సిగ్గు ఉండాలి. నేనేం చెప్తున్నా అన్ని ఒకటే క్వశ్చన్ చెప్తున్నా. ఈ పొద్దున్న నుంచి చెప్పిందంతా ఒకటే. ఫిక్స్డ్ యాక్సిస్ అయితే అబౌట్ ద యాక్సిస్ చేసేస్తాం. ఫ్రీ యాక్సిస్ అయితే కొల్యూషన్ స్టిక్ అయితే ఒకటి, స్టిక్ కాకపోతే ఒకటి. నెక్స్ట్, see this question. Everyone try to see this question. (23, 24) are based on the following physical situations. We have 2 identical dumbbells. The dumbbells are moving in free space with equal speeds u towards each other without rotation as shown in the figure. Collision between the particles are perfectly elastic. Okay, pa. And just after first collision, యు కదా, యు. అగ్రీడ్. ఏంటి అగ్రీడ్ రా, నిద్రపోతున్నారు మీరు. దట్ ఈజ్ నాట్ అగ్రీడ్. ఇది కూడా ఉండాలిగా. యు. బాగా గుర్తుపెట్టుకోండి, ఇది సెంటర్, ఇది సెంటర్. ఇది కొల్యూజన్ లైన్ ఆఫ్ ఇంపాక్ట్. కొల్యూజన్ లైన్ ఆఫ్ ఇంపాక్ట్. నెక్స్ట్ స్టేజ్ ఏంటో చెప్పండి ఒకసారి. నెక్స్ట్ స్టేజ్ ఇది ఇక్కడే ఉంటుంది, ఈ సెంటర్ ఇట్లానే ఉంటుంది. నెక్స్ట్ స్టేజ్ వచ్చేసి నెక్స్ట్ స్టేజ్ వచ్చేసి ఏమవుతుందో చెప్పాలి. నెక్స్ట్ స్టేజ్ వచ్చేసి ఇక్కడ కొల్యూజన్ లో జరిగే పార్టిసిపెంట్స్ ఏంటంటే 1, 2, 3, 4. 2, 3 కొలైడ్ అయినట్టు ఇప్పుడు. అలానే మీ 2 ఇక్కడికి వచ్చింది, 1 ఇక్కడికి వచ్చింది, అలానే 4 ఇక్కడికి వచ్చింది, 3 ఇక్కడికి వచ్చింది. ఇప్పుడు ఏం జరుగుతాయి? కొల్యూజన్ బిట్వీన్, ఒక్క నిమిషం ఆగు. ఓకే కదా. ఇప్పుడు ఎవరికెవరికి కొల్యూషన్ జరుగుతుంది? 1 and 4 కొల్యూషన్. కొల్యూషన్ తర్వాత ఏం జరుగుతుంది? జస్ట్ కొల్యూషన్ తర్వాత ఏం జరుగుతుంది? యు 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 అండ్ యు. ఇంతకీ ఇది 4 అయితే పేర్లు చెప్పుకోవాలిగా మనం క్లియర్గా. ఇది 4, ఇది 4, ఇది 3, ఇది 1, ఇది 2. రైట్. ఏం జరగలే అక్కడ. ఇదే డంబల్గా ఆ డంబల్ ఇన్వర్ట్ అయినాయి అంతే. సో మొత్తం ఎన్ని కొల్యూషన్స్ జరిగినాయి టోటల్గా? 2 కొల్యూషన్స్. జస్ట్ ఆఫ్టర్ ఫస్ట్ కొల్యూషన్, just after second collision. So try to please understand, only 2 possible collisions are there. Yes or no? Thereafter, this will translate leftwards, this will translate rightwards. So therefore, 2 collisions took place. Angular velocity of each dumbbell after the first collision is. ఇందులో చెప్పేదే ఉందప్పా. You said this is U. You said this is U. So with respect to this, omega is 2U by L. అంతేగా? Right. With respect to this, actually, 2U. 2U by L. Yes or no? దీన్ని మనం ఏమని పిలుస్తాము? 1, దీన్ని 2. Immediately after collision. Any doubts? Pakka. Just before first collision, what is the angular velocity? Just before first collision, what is the angular velocity? Just before first collision, what is the angular velocity? Zero. Enduko there is no rotation. Purely translation. Just after second collision, what is the angular velocity? Zero. Clear? Pakka? Right. We'll move on to the next question. Today I'm discussing completely point mass collisions. Please go through this question clearly. You have a rigid massless rod of length L. I don't see any difference between the one which I have done right now, this one, and this particular question. Both are more or less the same. Okay, right. What to do initially is you can apply law of conservation of linear momentum. Why? Because this is a free access system. So by applying that, you will have mv naught is equal to, see, what I assume is this is initial. So immediately after collision, let us assume this is having some v1 velocity and the center of mass is assuming a velocity vcm and angular velocity. Actually, I think I should take this in opposite sense because the impulse is in this sense, right ways, omega. Are we clear? After collision, just after collision. So mv naught is minus mv1 plus 2m vcm. Let this be equation 1. Law of conservation of linear momentum. Now, law of conservation of angular momentum. Tell me which point you suggest. About a point just below the center of the rod. Law of conservation of angular momentum about a point just below the center of the rod. So in that case, initially this is at a distance L by 2 root 2. Yes or no? Hello? This is L by 2. This is L by 2 root 2. So mv naught L by 2 root 2 is equal to minus mv1 L by 2 root 2 plus, already we have done calculated moment of inertia of this system about ICM. This is nothing but 2 times m L square by 4. This will become ml square by 2 plus ml square by 2 times omega. Agreed? And this will become equation 2. Clear? What are unknowns? Unknowns are V1, VCM, inka omega. Unknowns. So you require one more equation. What is the other equation? Coefficient of restitution is equal to 1. So E is equal to 1. Okay? By substituting E is equal to 1, you will get the condition at this point. Relative velocity, no, see, try to please understand this particular system will have two velocities. One is VCM, the other one is making an angle 45 degrees, L by 2 omega. So E is equal to 1 means VCM plus L by 2 root 2 omega minus V1. Relative velocity of separation is equal to relative velocity of approach. So now let this be equation 3. Remember, you have 3 unknowns and you got 3 equations. Now solving which already I have given you the notes. Solving 1, 2, 3, we will get omega. Trust me, omega, you will get it as 4 root 2 by 7 times V naught by L. Okay? So if you have omega, you will have everything in this. Any doubts? That's all. You need to find omega, and that I have given. Any doubts, please ask me. If you have any doubts, please ask me. Please try to understand. I am repeatedly giving you the same situation all the time. Next question. Go through this. Two identical thin rods are moving on a smooth table as shown. Both of them are rotating with angular speed omega in clockwise sense about their centers. Their centers has velocity v in opposite direction. The rod collides at their edge and stick together. There will be no motion after collision. Now, which point you prefer? This is the point about which this is a point attached to the ground. This is a point fixed to ground, fixed to table. Let this be point A. So, total angular momentum is L1 plus L2. See, please try to understand. L1 means first rod, L2 means second rod. V, ఇప్పుడు చెప్పాలి మీరే. M, 1 minute. Formula ఏంటి? ICM omega bar plus RCM bar cross MVCM bar. అంతే కదా? నేను ఇదే వేస్తున్నా. ఫస్ట్ వచ్చేసి మీకు రాడ్ ML square by 12 omega minus K cap. Plus MVL by 2 K cap. ఇది ఫస్ట్ రాడ్కి. రే సెకండ్ రాడ్ కూడా సిచ్యువేషన్ అదే. సేమ్ చూసుకోండి, మీరు కావాల్సి వస్తాయి. ML square by 12 omega minus K cap plus MVL by 2 K cap. There will be no motion after the collision అంటే ఇది 0 కావాలి. టోటల్ ఇనీషియల్ యాంగులర్ మొమెంటమే 0 అయింది అనుకోండి. దట్స్ ఆల్. అది జరగాలి అంటే ఏం జరగాలి మీకు? ML square omega by 12 MVL by 2 కావాలి. M క్యాన్సిల్, L క్యాన్సిల్, అప్పుడు V వచ్చేసి ఏమవుతుంది? V by L omega ఏమవుతుంది? 1/6. This is nearly 0.1666 So nearly 0.17. అయిపోయిందా? క్వశ్చన్ చూస్తే ఎంత భయంకరంగా ఉందో చూడండి, సొల్యూషన్ చూస్తే ఎంత సింపుల్గా ఉందో చూడండి. మనం ఇదే మిస్టేక్స్ చేస్తాం. నాకు అక్కడ హింట్ అల్లా నో మోషన్ ఆఫ్టర్ కొల్యూషన్. సార్ మరి ట్రాన్స్లేషన్ నీ బొంద, ఆల్రెడీ ట్రాన్స్లేషన్ క్యాన్సిల్ అయ్యే ఉంది ఇనీషియల్గా, ఆపోజిట్ డైరెక్షన్స్. ఓకేనా? నెక్స్ట్, నేను ఆర్డర్ ప్రకారం ఎందుకు వెళ్తానంటే టైం మేనేజ్మెంట్ ప్రాసెస్ ఇది. రైట్, గో అహెడ్. మేబీ లాస్ట్ క్వశ్చన్ ఫర్ దట్. Horizontal disc, mass 1 kg, mounted on a fixed vertical axle through its center, can rotate without friction. On the disc, a semicircular groove OP is cut. A small ball B of mass 1.5 kg, when pushed on the disc towards the center O, the ball enters the groove with a speed of 2 meters per second and moves through the groove without friction. With what speed will the ball leave the disc? Neglect loss of mass due to cutting the groove. Good question. First of all, in this case, there is no loss of energy in this case. So therefore, total energy initial, total energy final. Basically, it is purely kinetic format. Half mu square initial. What is going to be the final? The point mass will comes out with velocity v, and the remaining portion of the disk will have omega. And I mean, immediate by the time it comes out, this point will come out with velocity v, and this will have an angular velocity omega. Clear? But angular momentum also conserved. L initial is L final. L initial 0. Why? Nothing is there for you. L final mr square by 2 omega minus plus mvr. Okay, so now you have, what are unknowns? Omega is an unknown, v is an unknown. You have two equations. By solving these two equations, you will get a condition that u square is equal to v square times 1 plus mr. Yes, actually, I don't know whether they didn't given anything about, right? Hello? Now you see, that is how you will manage. See, angular momentum conservation is a major role using one and unknowns. You see, the entire day I have solved all the questions in the same day. I identified unknowns. Accordingly, I have planned equations using 1 and 2. Right. So that's all for today. But let me just count how many questions are pending from my end. All these I have covered, I think. There is no pending in this. No pending in this.